So in this video, we're going to talk about solving logarithm equations. So let's take a look at one of the example. So example, if I have log base 4 of x minus 2, that will equal to 2. Now to solving for this logarithm equations, now this is our first step. We try to write as an exponential function. So write as an exponential function. So when we try to write an exponential function right here, then we know that 4 is the base, and then 2 is the exponent. So the way we rewrite it, that will be 4 squared, and then that will equal to x minus 2. All right, so we write in the exponential function here, and now 4 squared, then that will equal to 16, equal to x minus 2, and then we're adding 2 for both sides. So we'll get x equal to 18. All right, so x is equal to 18 will be our answer for that. And another type of question is a little bit more complicated. So is you are given log base of x and then plus log base 6 of x plus 1 equal to 1. Now the question for this one is become 2 logs adding together. But luckily right here we have the same base. We have base 6 here, I have base 6 here, and then we have plus here. Now, in this case, that will indicate that we're going to using the product property. All right, so the product property right here now come from the law of the logarithm, which means if I have log base b of x plus log base b of y, so that will equal to log base b of x times y. So you need to be careful with this notation right here. This is a times, this is a plus. All right, so when you expand it, that's a plus. When you combine them, is multiplication. So expand is plus, and the combine is multiplication. So now in this case right here, my function, I can just combine them into log base 6, and then it will be x times x plus 1 and equal to 1. Now, once we change them into the same one, well, we're just gonna combine them into one logarithm, then we can now write it as exponential form. So which means, again, my base is 6, my exponent is 1. So I will have 6 to the first power equal to x times x plus 1. And now after that right here, we're just going to solve for this quadratic function. So we'll have 6 equal to x squared plus x. And then I'm going to move the 6 to the other side and change that into x squared plus x minus 6 and equal to 0. And then we're going to try to factor this. So we'll have x plus 3 and x minus 2. So now in this case right here, now I'm going to solve for x. The first one, I'll get x equal to negative 3. And second one, we'll get x equal to 2. But just to keep in mind that for the log function right here, if we have log b of x, or y equal log b of x, we know that the domain for the log, which is x, has to be greater than 0. So it doesn't matter what we have right here. So I'm going to leave it blank here. But I know that this part has to be greater than 0 only. So that's why I need to check my answer. So this is very critical for solving the logarithm right here, is you have to double check your answer. So let's check it. So when x is equal to negative 3 here, I will end up with log base 6 of negative 3, and then plus log base 6 of negative 2. And now in this case, I don't have to continue to solve because this negative 3 is less than 0. This negative 2 here is less than 0, which means x is equal to negative 3 cannot be our answer. So cannot be the answer. right? So we need to reject x equal to -3 then. And now let's take a look at x equal to 2. Now if I have x is equal to 2, then my left-hand side, I will have log base 6 of 2 plus log base 6 of 3. And then my right-hand side right here, I know that equal to 1. So let's just see if my left-hand side equal to 1. So I can combine them together. I will do log 6 of 2 times 3, so which is log base 6 of 6. And then that will equal to 1. So right here, my left equal to right, and then check. So that's why right here, my final answer will be just x equal to 2. All right, so now similarly, if I have a type of question with log 5 of x minus 1, and then minus log 5 of x equal to 1. So now again, by the quotient property, of law of logarithm, so we'll have log b of x minus log b of y, that will equal to log b of x divided by y. All right, so now in this case, which means I will change my minus, combine them. So combine. So I will have log base 5 of x minus 1 over x, which is equal to 1. And then we're going to rewrite in the exponential form. So which is 5 to the first power will equal to x minus 1 over x. So we got a 5 is equal to x minus 1 over x. And now here I can just rewrite my 5 into 5 over 1. And then do this cross multiply. So I will end up with x minus 1 equal to 5x. So in this case, we'll have 4x is equal to -1. So x is equal to -1 over 4. Now that will be my only answer, but again, don't forget I need to check. I need to check my answer. So when you have x equal to -1 over 4, that means I will have the left is equal to log 5 of -1 over 4 minus 1 minus log 5 of -1 over 4. Now this -1 over 4 apparently that's less than 0, and -1 over 4 minus 1 is apparently is less than 0. So in this case, x equal to -4, -1 over 4, we need to reject. But since -1 over 4, that's the only number we got here, and as we check, we rejected. So in this case, your answer will be empty set, or you can call this as a no solution. Or you can say no real solution. All right, so it has happened that we do not have any solution, or maybe we're gonna reject one of the solution, or maybe we can keep both. All right, so that's why it's very important right here that you need to check your answer, right, for each one right here. I'm gonna put one more star for this. All right, so if you would like to, again, you can try some questions as a practice. So the first question you can try is log base 2 of x minus 1 equal to 5. And then the second question you can try is natural log 3 plus natural log x equals to 2. And then the third question right here you can try is common log of x plus 3 equal to 1 plus common log of x. And then again, the answer will be in the description, and you can check it out after you finish your question.